Okay, so we saw the block. So what we're going to do as we were saying, is we're going to be taking that corner of that block and milling it off to make that surface like that. Now I'll give you guys a minute to draw that out here because I know it might take a minute. So what we need to do here is we need to figure out what dimensions are we going to give you. And the dimensions we're going to give you are both going to be angles. This is why we ended on the angles from the last one. So if we're looking at the front view here, it's going to be cut like that. What I want to say is this angle here, which I'm going to call angle A, and we're going to call that 20 degrees. Then this right end view, bless you, is going to have another angle, which we'll call angle B, and in this case, I'm going to call that 30 degrees. So the first thing we need to find, well, one of the things we need to find is we need to find the angle of rotation. The angle of rotation is going to be, if I go from this corner that's going to be missing to this line here, which is going to be our new edge at a perpendicular. This angle here is how far we have to rotate. Because if we think of this as being the front edge of the piece here, that edge, when we set it down, is going to be lined up with the front of the table. We have to rotate it from that edge to that axis there so that this line here is going to be perpendicular. So rotating it to that edge, that line there is going to make it in that orientation. No, it's not. This here would be the 20 degrees up here. This would be the 30 degrees over here. So what we're going to need to do is put some dimensions in there. Now, just like with the drilling problem where we had the two angles, we don't have to have the dimensions. All of the angles here are defined by those two angles. But it's a lot easier to find the other angles if we have angles to go with these. So what I'm going to do is I'm going to define, I'm just going to create a distance right here. And I'm going to call that distance 10 millimeters. Why 10? Well, because I think 10 is easier to work with than 7.2. Now from that 10 millimeters, I have two right triangles here, one on each side. I can find this dimension, which is just going to be that dimension there. And I can find this dimension, which is going to be this one over here. And of course, this is the one right here. This dimension is the one that we put the 10 millimeters on, just as a working dimension, right? So again, just like before, that 10 millimeters is a totally made up dimension, but the angles don't depend on any lengths, they just depend on the other angles. So how would I find, if I call this length here, I'm going to call that little a because it's with angle little a, and this little b here because it's with angle, or angle big B. How would I find little a? That's opposite and adjacent, right? They're the two legs. So it'll be the tangent of 20 degrees equals the 10 millimeters over little a. So I put this over 1, I'm going to cross multiply. 1 times 10 is 10 divided by the tangent of 20 degrees. So at 27.47 millimeters. Over here, for B, I have the tangent of 30 degrees equals 10 over B. So to solve for B, I put that over 1. I'm going to cross multiply and divide. 1 times 10 is 10 again, divided by the tangent of 30. 17.32 millimeters. Now that I have those dimensions, I want to look at this triangle on the top up here. I'm going to draw it right down here. Maybe I'm going to draw it down there. This here is a right angle. That's just the corner of the block. This here was the 17.32 millimeters. Over here it was 27.47 millimeters. Well, we don't necessarily need that length, we need some angles. So I'm going to look for this angle right here. I'll call that angle D, doesn't really matter. How would I find angle D? Tangent of D equals, the opposite side would be 17.32 over the adjacent side by 7.47. So since I'm looking for the angle, I'm going to use inverse tangent. So the inverse tangent, 17.32 divided by 27.47, 32.23 degrees. So now remember the line that I'm looking for, the first line I'm looking for is this line right here that's at a right angle there. Now remember, my angle of rotation is this angle right here. That's R, my angle of rotation. That angle is relatively easy to find right now. Because that's a right triangle. I have a right angle here. This is my 32.32. So I subtract that 32.32 from 90. Gives me 57.77 degrees. That's my angle of rotation. Does everybody see where I got that angle of rotation? Okay, now back up to the main triangle, the main box here. I got to draw this a little different. So now, we'll try that a little bit bigger. Oops. So what I just found there, I put these lines kind of in. Is I found this angle right here, that's R. My angle of tilt is going to be the angle underneath that line. Oops, be a different color here. This angle right here is going to be my angle of tilt. So if I look at that from the side, there's my tilt. That's a right angle. That's just the corner of the block here. This height is going to be that 10 millimeters that we made up. This length here would be the length of that line. Does that make sense? So I got to go back and find the length of that line. Well, this is the hypotenuse of that triangle. This would be the opposite side, so that's going to be sine of 32.23 degrees equals that opposite side, which I'm going to call side little d because it's across from angle big D there. It's going to equal little d over 27.47. So to find it, I'm just going to cross multiply and divide. Sine 32.23 times 27.47 divided by 1, 14.65. So that's 14.65 from here to here. So that's 14.65 right here. So T, my angle of tilt, is going to be the inverse tangent. What's the opposite side? The 10. The adjacent side? 14.65. .32 degrees. That's my tilt. So I have to rotate it that 56 or 57.77 degrees, and then tilt the table 34.32 degrees. Now, like I said before, the math here is all math you've done before. It's just simple right triangles. Way easier than the oblique triangles we finished up with. The tricky part is seeing them because some of them lie flat, some of them are up and down, some of them are at an angle. There are triangles in every which direction. I realize that. So what I'm going to do is we're going to do an example here, and we're just going to do it piece by piece. It's going to be best if I draw it this way. So here we are. Let's say from the front view, this is our angle A here. We're going to call that 18 degrees. Over here is our angle B. We're going to call that 23 degrees. This here, we are going to assume somebody pick a distance they want to use there. 20 millimeters, okay. So we're going to assume that's 20 millimeters. What I want you guys to find first here, using this purple triangle up here, I want you to find R. I'm going to give you a couple minutes to see how well you do on that. In about 2 minutes, we'll stop and maybe give you some hints if we need them. Then we'll move on. So one of the first things we need to do is to find this dimension here, which would be little a, and this dimension here, which would be little b. Of course, little a goes from here to here. What'd you come up with for that? $61.554. So 20 divided by tangent of 18. Yes, 61.554 works for me. And for B, of course, that's from here to here on this side. That's the tangent of 23 equals 20 over B. What'd you get for that? 47.117 sounds about right. So now that we have those two dimensions, what would be our next step? Find angle D there, right? If I find angle D, how am I going to find D? Inverse tangent of, what's the opposite side? 47.117. The adjacent side? 61.554. If it helps, you can pretend that line isn't there yet, right? That green line in the middle. So we would get 37.43 degrees, we'll call it. So that means then back to putting this line back in, R would be our angle of rotation. How do we find R? Perfect, 90 minus the 37.43, which gives us 52.57. degrees. What do you think? Not horrible? So that's that side right there. That brown one matches up with this green one right here. So now we've got to come up with that angle of tilt. I'm going to give you guys a couple minutes, see what you get there. So what's the first thing we need to know here? We need to know that length across there, right? How do we find it? We'll call that little d. Yes, this is 37.43 degrees here. That would be the opposite side. We have the hypotenuse. So the sine of that 37.43 degrees equals that opposite side. I'm going to call it side D over that hypotenuse of 61.554. That sounds about right. Oops, helps if I get the right angle there. $37.41, did you say? I think I got everything punched in, right? Oh, gotcha. You did cosine instead of sine? Should have still worked out to be about the same, which it did. So 37.412 millimeters we get there is that length. So then to look at this triangle here, what we have on top is what we just found, the 37.412. This was the 20. Our tilt is this angle right here. How do we find that tilt? Inverse tangent, 20. for 37.412. Very good. (28.13 degrees). So that's our tilt. What do y'all think? It's a lot of triangles to see. Well, I think you guys want to do one more example together, or do you want to start on them? See what you can do on your own. Do one more? Okay. Why not? No extra charge for an extra example, right? So I'm gonna give you this angle here, 15 degrees. This angle here is 25 degrees. This distance, let's just call it 10 millimeters to make it easy on us. And I want you guys to go all the way with this one. Find the rotation and the tilt for me. We'll give you a few minutes. Let's see how this is going for you. So we're going to find this length right here. That's going to be the tangent, 15 degrees equals 10 over, we'll call that little a. So 1 times 10 divided by tangent of 15. Sounds about right. 37.32 looks correct. Millimeters over here. Okay, that'll be that one. That's tangent 25 equals 10 over little b. What'd you say it was? 21.45 millimeters. Sounds great. So then we're going to find this angle here, which is going to be the inverse tangent. 21.45 over 37.32, otherwise known as $29.89 works for me. So that means I draw that in at a right angle. Our angle of rotation right here is 60.11 degrees, correct? We need this length here. That length is going to be the sine. 29.89 degrees equals, call that little d, so d over the 37.32. Put that over 1, so it's just going to be 37.32 times the sine of 29.89. Divided by 1 won't change anything, so it's going to be 18.60. So now we come back here. We're looking at that triangle in the red there. So that triangle, this top is that 18.60 that we just found. This is the 10 millimeters that we guessed, started off with. This is our angle of tilt. That angle of tilt, the inverse tangent of the 10 over 18.6. Sounds right, 28.26 degrees, which is our tilt. Anybody have it all right? Anybody on their way, just needed more time? Anybody want to go home, bury their head in the pillow and cry? So in the new packet that I handed out while you were working on that, are we looking at pages 410 through 411? 1 through 13, the odds. Tomorrow we can do some more examples of this if we need to. Otherwise, we move on to intersecting angular surfaces. What that would be, let's take our block again. And what we would be doing is we would be taking and cutting like this. But then we would also be taking and cutting it going this way. So it's going to look like that. So what we're going to find is the length of this edge, what angle it is if we were looking at it from the top, what this angle here would be our rotation again. Well, we'll do it in more detail tomorrow when we're actually doing it. Then our angle of tilt is going to be this angle right here. But that will be tomorrow. So for today, 410, 411, only 7 problems to do. Realistically, I know that's 7 huge problems. If you get 3 or 4 of them done, I'll be happy. You guys know that you're only here to entertain me for 16 weeks. And you're